Hello, students. Once again, you're welcome to Waidsum University. Okay, this is chapter 4, part 6. For this chapter has 6 sections, so this is the last section of this chapter. Okay, so and this section is troubleshooting wireless network. Now, without much ado, let's begin. Now, troubleshooting, first of all, every system that's configured usually have one or two issues which can be resolved by carefully looking at the following aspect that we want to talk about. For this section, we will examine some very important or common techniques that are used for troubleshooting wireless network. Wireless network have greatly simplified the steps for connecting to any network, right? But wireless networks do sometimes fail because of issue here and there, which we're going to describe. Okay, now the following are some scenarios that the user might encounter the outline steps for troubleshooting and resolving wireless network. Now let's take a look at the steps that we might use to resolve our wireless network. The first one is the hardware issues usually coming with the wireless network. Our primary hardware devices in wireless network is the access point. The primary hardware device in every let's take a highlighter. I think we need a highlighter or something. Okay, the primary hardware device in troubleshooting wireless network is the access point. Okay, access point. Now this access point is very important, and every time we have issues, the first point of contact we should check is to ping the access point, to check the access point. In some cases, you may have multiple access points in your network, right? You may have more than one access point. So we can easily verify each of these and as it were, right? Now, a simple step, first step is to ping the IP address for the access point. To ping it, okay, do the IP config for the access point to check if the access point is connected to your network. If there is an establishment, okay? If there is an establishment between the access point and your network. Now, the purpose of the ping is to verify that you have network connectivity. Is to see why we do the IP config is to verify, or is to check if we are connected to the network. Now, if the access point is connected to the network. Now, if the if the ping doesn't work, then we try unplugging the access point again and then replug it back. If you do the IP config for your access point and it doesn't work, you don't see a connection with the network, then you have to unplug your access point and replug it back and see if this time around the problem will be resolved. Most likely, if the problem is from the access point connection, then probably you replug and plug it back, the problem might most likely be resolved. This will help to reset the access point. We reset the access point. Once you unplug and replug back, it will reset your access point, and that might just be the solution that you're looking for. Now, another troubleshooting issue is to look at the signal strength problems, because we do normally have a problem emanating from the signal not be strong. Maybe initially it was strong, it was excellent, later it become just good or even weak signal. So we find out what are the problems that can cause this kind of issues. Now, the purpose of measuring the signal strength is to verify that you have good signal level at the received location. At your location, you have a good signal level. You must have a good signal level, and so you have to measure the signal strength constantly, okay, to verify that you have a good signal level. Now, things might change, and a loss of signal strength might not be a problem with the access point. Maybe you're losing signal is not because of your access point. It could be that there are other things that are blocking the signal within your location. Is that okay? Now, it is possible that something could have been moved or physically is blocking the signal. Maybe you move something to block the signal, or something is physically blocking the signal. So you have to find out if there are such problems, so you quickly do a resolve, okay, as a system administrator. Now let's move on. Now, still on troubleshooting, we're looking at the frequency interference, because there are other interference like the microwave interference, because microwave frequency is 2.4 gigahertz, so it can easily interfere with the frequency of your signal. in 802 IEEE 802.11b and IEEE 802.11g, IEEE 802.11n. So all these devices can easily interfere with your microwave. So interference is a big issue. So we say there are also there might also be an electrical device such as a microwave oven. A microwave oven. Okay, microwave oven has same capacity, same bandwidth with your IEEE 802 standard that we're talking about. So could be causing interference because they have same frequency. Could be causing interference. Microwave ovens operate at a frequency of 2.4 gig. And remember, this is the same frequency for the 802.11b, 802.11g, 802.11n. So this is the same frequency with all of this. So there could be interference once you have a microwave oven operating close to your network. Now, it's always good to have a baseline measurement of the signal strength expected at each location for situations such as this. So you have to measure your signal to know whether anything has gone wrong or whether you've received what you expected to receive. Now, let's move on quickly. Still on troubleshooting, we look at the load issues. Wireless users share same frequency channels to communicate to same access point, right? So if too many users are connecting at the same time to the same access point, there might be your network may start experiencing what we call slowness. If there are many users connecting at the same time or using the same network, connecting at the same time to the same access point, there may be what we call slowness, okay, slowness and packet drops. There may also be another issue called packet drops, okay. So if many people are you have many users in your location trying to access at the same time, so there may be slowness and packet drops. Now, for optimal load capacity, one should consult the documentations of the access point manufacturer. So if you want to know what is the maximum number of people or documentation that can transmit at the same time, or that should be on the user for a single access point, then you should consult your manufacturer, okay? The manufacturer of those equipment, of the access point. So like Hawaii is also a manufacturer of this type of equipment. So probably you could consult or see the guideline, the guideline, okay, for the procedure for usage. In the guideline, you see how many users are supposed to be on a single network with one single access point. So when you follow this, you do not overload or you do not overshoot. You do not know too many users more than the capacity that is supposed to carry. Then if it's more, then you have experience what we call slowness and packet drop. Okay, and these are issues which, as a system administrator, you should know, should be conversant with, and you should be able to clarify the users in your network. Is that okay? That you're managing. Now let's take a look at still on troubleshooting. We're looking at the DHCP issues. Now, your access points typically assigned the 192.168.0.x address to the client. Okay, so your access point dynamically have something like your address, your IP address, okay, to the client. Okay, you can verify the IP address assigned by entering the command ipconfig from your command prompt. Okay, you look at the ipconfig in your command prompt like we described in chapter 2. Is that okay? And then see what is running, whether you dynamically be accessing your IP address. Okay, this could be an issue if it's not there's no connection, then you do the usual that we've described in chapter 2. Now let's take a look at other issues that may come up again. Is the SSID issues. The SSIDs. Once the SSID, your service set identifier, has been configured for a computer, then this normally does not require a configuration. You don't have to, once your SSID, because it's like a password, once it has been configured for a computer, then these normally do not require any reconfiguration. However, sometimes when you travel, you do need to reconfigure your SSID to connect to a different network when you travel, okay? The moment you're back to your home network, then you have to reset your SSID. You have to do what we call reset. When you are back to your same home network, then you do what we call reset. Okay, so your SSID is usually once you are configured, that you've log on, you'll be created with the password, you log on to the network. It's once. Okay, you don't have to log in every time, okay, in that same network. However, when you travel, you normally have to reconfigure your SSID to connect to a different network in wherever you have traveled to. And the moment you return back to your home network, then you have to reset your SSID to the default set, to the original, the first one, the first case. Is that okay? So that's all for this. Now let's move on quickly. Say security on troubleshooting, security Wi-Fi. Most wireless systems support multiple network security protocols. Okay, like e.g. the different versions of the WPA and WEP. Most wireless networks they support multiple network security protocols, right? Now, but one thing you have to ensure as a system administrator is that you have to make sure the client and the access point are running the same security mode. Because if they are not, then there will be issue. There may not be connections. Okay, they are running on the same security. The client and the access point are running on the same security mode. Now, okay, so we say anytime you are connecting your wireless device to a public hotspot, there is a chance that someone might be using a packet sniffer to probably see your data traffic. So you should be careful when you're using your wireless devices to a public hotspot. Okay, should be careful. When you do this, someone might be sniffing and your packet traffic can be observing you and plan attack on you. Is that okay? So which is not good for you. So you can avoid possible problems by enabling WPA to secure your data traffic. So once you use WPA to secure your data traffic, then people might not be able to sniff your network through your network traffic or your data traffic. Is that okay? Okay, now let's move on quickly. We say selected wireless channels. Now you know the default channels for 802.11b and 802.11g router is channel 6. That's the default by standard. Default channel is channel 6. Now if you have interference problem, then you can change your channel maybe to 1 instead of 6, or you can change it to 11 instead of 6 if you have interference problem, right? Now the RF spectrum, radio frequency spectrum on these channels do not overlap. They don't overlap, okay? So that's good, right? Now this will most likely solve your problem. This will most likely solve any problem that is coming from your wireless channels, okay? So once you have problem with the channel 6, you can switch to 1 or 11, okay? So that your problem could be solved. Is that okay? Now your 802.11b and G wireless router have 11 possible channels. They have 11, so you can switch to any of this one that we designated. Okay? They have 11 possible channels and selections of an alternate channel that is managed via the wireless router setting. There's an alternate channel that is managed by the router settings. Is that okay? Now let's move on quickly. Now extending the wireless range. Now one of the if you are extending your wireless range, one of the things you ensure is that your antenna is placed on a very high altitude, okay? Placed on hilly area, mountainous area, or you build a tall mast for it, okay? You build a very big, huge, tall mast for it so that there will be a clear view, a clear line of sight, and so that we ensure that your antenna is not be obstructed by any metal. And not only metal, even your concrete, buildings, bricks, okay? But metals, remember, they reflect your signal. They reflect the signal from the antenna, so you're not going to get what you're supposed to get. So that's the reason why we have to place our antenna from our proposed site or the telecommunication site. We have to place the antenna on high mountains or high hills, or probably build a mast, a telecommunication mast, so that we can place our antenna far tops, so that it's clear view. We have clear view of several kilometers from all directions, probably, and even more than that, so that we can our signal will not be obstructed by metals. Now, when your signals are obstructed by metals, they will be reflected, right? And that is not good for transmissions and reception. Now, it's important to remember that the radio waves will reflect off any metal surface. When they hit any metal, they will be reflected off. So your signal is not going to, your radio wave or signal is not going to go the direction that you sent it to. Okay, so this is very important. Also, surfaces like concrete, not only metal objects, concretes are bricks, they attenuate our signals. So we must ensure that that's why we have to place the antenna very tall, high end to reduce attenuation of signal. Because even if they do not reflect it, they attenuate it. They gradually make it weaker and weaker and weaker. Okay, so we say surfaces like concrete, surfaces like bricks, they will attenuate the signal. In some cases, it might have to use a very high gain antenna to receive or to help boost your receive signal strength in your receive end. Is that okay? You have to use a very high gain antenna, so which is costly in any case. Okay, now let's move ahead quickly. Now we say selective wireless channels. Selective wireless channel. I think we've already talked about this. Okay, we say that the default channel is 6, and we've talked about it. Let's move on quickly. Now, wireless compatibility. Not all wireless CLETs are created equal, as wireless CLETs depends on their hardware and software. Not all of them are safe, because probably each one depends on the type of hardware and the type of software that is running with. Now, also, in order to have a reliable and good throughput wireless connectivity, if you want to have a reliable and good throughput wireless connectivity, both the wireless access point and the wireless CLET must be compatible to use they must be compatible, and they have to use the same standard. They must be the wireless access point and the wireless client. That's your users. The wireless client, they have to be compatible with their standard. If you're using 802.11a and 802.11b, that's not compatibility. That's not compatibility. So both the telecommunication closet and the CLET area, workplace and work area, they have to have the same compatibility standards. Okay, like using the same IEEE 802.11a or using IEEE same IEEE 802.11b. B is compatible with bank, compatible with G and N. Okay, so we can use this one that have a very huge back compatibility. Okay, now let's move on quickly. We say the IEEE 802.11n is a standard that can offer connectivity in either the 2.4 gigahertz frequency or the bandwidth, or 5 gigahertz bandwidth, or even both of them. Now, this means that a wireless client can be 802.11n, and is compatible just by operating in one frequency or both of them. So you can see a CLET can use this because it is compatible with 802.11b and 802.11g, and or is even compatible with this single frequency or bandwidth, or compatible with both of them. So this is what we are saying, that there's both the user, the client, and what you call the wireless access point must use the same standard in order for us to move forward. Is that okay? Now let's move on quickly. Now, cable issue. Despite you're using wireless, sometimes problem could also be due to simple physical cable connections in your system, because despite you're using wireless, your hub and switch, they are connected with cable, and they're plugged to the wall. They're connected to the wall so that electricity supply can get it to them. So in one way or the other, there is a cable somehow a little bit with the hardware devices. Okay, now, so in as much as you're good, wireless network is good, and it requires little cabling, but there is still need for us to check the cable in case the signal is weak or the signal is not doing well. Now, the cable could be loose or has become disconnected, or the cable could be bad, either loose or disconnected, or the cable itself is already bad. So it's always good to have a spare cable just in case any of this happen. So cable could be loose, that's one. Cable could be disconnected. Two, cable itself could be bad. So we need a spare cable always, to have a spare cable as a network administrator in case, or not even just one spare, you have more than one in case something happens, so that you can have something to use to quickly bring back your network. Remember, you can always verify you have a connection by checking the presence of the link light. There is always a link light in your switch or your hub. Okay, so you can always, once you see the light blinking, then you know you have a connection with your wireless. Is that okay? Now let's move on quickly. Now switch uptime. Another troubleshooting area we can look at or we can harness is the switch uptime. Now, a common task for the network technician or administrator is to verify the switch uptime for is to verify the uptime for switch or switches. Now this will help identify potential problems with switches that might be intermittently resetting. Okay, it could be that the switch is just rebooting. You have to check the uptime. So the command for viewing the switch uptime is switch #show version. Switch #show version. Now, once you write this command on your system, now then you'll be able to see whether the switch was rebooting continuously or constantly, or whatever problem it has. Now, the reasons to check the uptime is to see if the switch is or has been rebooting. Now, rebooting problem can be due to power fluctuations in your system or a switch problem. In either case, the network technician needs to know, so in order to identify the problem and also provide a solution to this type of problem. Okay, so now let's move on quickly. With this, I think we've come to the end of the switch uptime problem. Being able to first of all locate the switch, then we've come to the end of our this section. Okay, thank you very much.